if we now know what the costs are, right, but we're then thinking, well, these costs are a little bit high and I need to bring that down, which I'm sure is a conversation that you often have, right? How would we perhaps massage those costs?
Well, we need to let's take it back to the start. So we've got the product. Okay, we've validated the design. Everything's okay. We're now into cost down or the cost reduced version. Let's say, and I've already talked about sort of various different techniques or strategies with respect to value engineering or material substitution. But it really comes back to going back to the CAD. Okay, so it's back to the drawing board in effect. Okay, this is where the drawing, sort of the phrase comes from. So basically, we've got to look at really smart ideas with respect to the concept itself. And I've already touched on, yeah, can we combine two or more parts into a single part? Can we then look at, instead of having individual parts are made and assembled, can we have one single part molded or cast or welded, for example? And that is going to, reduce the cost from potentially a material usage point of view, certainly from an assembly timing point of view. What also is going to do is reduce your risk of error. If there's a reduced risk of error, there's a reduced risk of issues going wrong throughout the assembly and potentially in the market itself as well. Okay, so reducing risk all the way through the process, that means it's a more reliable product at the end of the process. Okay, so it's really looking at going back to the drawing board and seeing what can be done from an assembly point of view, from material option point of view, from material processing point of view. We need to potentially push back as a design team. We would then go back and have the discussion with a customer and say, okay, what are the options available? Can we go from stainless steel to mild steel? Can we go from mild steel to plastic? Can we go from plastic to a framework trellis work? So all of these options need to be looking at and evaluating at the same time. Now, some of these, the customers have, you know what, I don't even, I'm not sure whether that'll be strong enough. Okay, no problems. Let's run an FEA or finite element analysis to see if a particular structure is strong enough. Therefore, we can reduce a massive amount of cost because we've totally redesigned everything. So this is one area that we can actually look at, and this is all about designing for cost. Okay, this is the overall umbrella or the arching sort of aspect to this, Adrian. But when we're looking at all of this as well, and I'm not just talking about sort of mechanical things or aspects, this also rolls down into electronics. Okay, so what about the battery? Okay, so the battery is a big one. So how long does the battery need to last? Well, as long as possible. But how long is that? And what is it feasible? Now, in today's world, you got mobile phones. Nobody wants to plug their phone in every 5 minutes. Everyone expecting a full day's worth or a full day and night, and plug it in when you go to sleep. When you wake up in the morning, same thing. Is that practical for everything? No, of course it's not. It's not needed. Sometimes a little bit more is needed. For example, we've got a product that needs to be awake, let's say, but maybe not in full use, and that should have 1 week's worth of use before it's recharged. May have 1 month's worth of use before it's recharged. Some products need to be reevaluated with respect to, is that really the case? What if we can reduce that 1 month down to 1 week from a customer using point of view? And the customer say, okay, what impact has that got? Well, to be fair, potentially that's going to have a big impact because we can reduce the size and the capacity and the overall performance of the battery, therefore reduce the cost quite a bit. Okay, so it's no good saying as long as possible when it comes to battery use or product use with a battery. Let's look at it from a costing point of view, design the cost, as well as meeting the performance requirements that meets a sensible output, let's say, from a consumer point of view. And this is where your design team needs to have that conversation with you as a customer, as a product owner, and say, what's reasonable? You want to bring the cost down, but this is a big area, for example, on some of the electronic components, for us to actually bring the cost down if there's a compromise on some areas of the performance. Now, you may say, you as the owner say, no, absolutely, we cannot compromise on the performance. Therefore, we need to go back and have a look at the design in other areas. Okay, so but when we come to looking at constraints, we as designers or the contract manufacturer should be pushing back, okay, on you as a product owner, and to see what is available from a constraint point of view, a movement point of view. All right, so that's an important thing to understand. It's not the design team saying, no, it's not possible. You need to stretch the envelope here from a thought process point of view.